following first order ODE. So first order ODE just means you have only y prime, right, which means the first derivative of y. That's the thing you have. Okay, second order ODE if you have like y double prime. Okay, and for all the first questions, they are just separable ODEs. Separable meaning that, okay, with the initial condition. Separable just means that you can move everything about x to one side and move everything about y to the other side. Okay, so you can separate x with y. If you can do that for the ODE, that ODE is called separable. For example, here, the left-hand side, it's dy over dx is 3x squared y squared. So clearly you can move everything about x, right, including this dx and all the x squared part to one side. Okay, and you can move everything about y to the other side. Okay, for the constant, it doesn't matter, it can stay at any side. So it's 1 over y squared dy is equal to 3x squared dx. Okay, and then you can, because these two parts are the same, you can integrate them. They'll still be the same. So you can integrate both sides. Okay, here I write it as y to the power of negative 2. And the right-hand side is 3x squared dx. Okay, so if you integrate the right, it will be just x cubed. Right? If you integrate the left, it will be y to the power of negative 1, right? Negative y to the power of negative 1. Okay. And because here it is an indefinite integration, right? Indefinite just means you don't have anything. You don't have two values here, right? Definite integration, for example, integrated from 0 to 1. So this is indefinite, this is definite. So indefinite integration, you get the result, right? You need to plus c. You need to plus a constant. Okay, here, theoretically speaking, you need to plus c on both sides. But, you know, you plus an arbitrary number on the left, you plus an arbitrary number on the left. It's same as you just plus an arbitrary number, for example, on the right. Right? It's the same. They have the same effect. So you don't have to write plus c on both sides. Then just simplify it. Right, so here it's negative 1 over y is equal to x cubed plus c. And y is negative 1 over x cubed plus c. Okay. So do you have any questions so far? All right, then the last type, the last step is what's c, right? Just remember you still have one piece of information unused, right? This initial condition, when x is 0, y is half. So just sub in, right? When x is 0, y is half. So c must be negative 2, right? So c must be negative 2. So then our final answer, y is just negative 1 over x cubed plus c. Do you have any questions for this part? Okay, so just separate them, do the integration. So it's the same for all 4 different parts in part A. For example, y prime, it is 1 plus y squared x squared. Okay, again, it is separable because right, it's easy to move. Because it's a product, usually when it's a multiplication of some y and some x, it's easy to separate them. Right, here you can move everything about y to the left. Okay, so it's y over y plus 1 plus y squared dy. And move everything about x to the right. So it's dx, x squared dx. Then just integrate, right? Just do the integration. So again, for the right-hand side, it's just 1 over 3 x cubed, right? For the left-hand side, right, maybe you need to do substitution. right? You need to do a substitution method. So let's do it here. You integrate y over 1 plus y squared. So whenever you do a substitution, it's when you see one part of the function is a derivative of the other part of a function. Okay, first is because this is, if you just integrate this, it's hard to get the answer. Okay, it seems impossible to integrate this, but you notice that y is a derivative of y squared, right? With some manipulation of constant, of course. But essentially, y is a derivative of y squared. So you can just set u to be y squared. Okay, then your du over dy is just 2y. Okay, you manipulate the equation a little bit, which means half du is just y times dy. Okay, so this integration can be transformed into, here y times dy is just half du. Okay, so it's just half du. And 1 over 1 plus y squared, so it's just 1 plus u, right? Because y squared is u. Okay, then here, the integration is quite clear, right? Because log x, the derivative is 1 over x when x is positive. Right here, your u is y squared, it's always non-negative. So the result is log 1 plus u, right? Half. Okay, and one last step, because your u is y squared. Okay. So here, the left-hand side is half log 1 plus y squared. Okay. And don't forget about plus c, right? Plus c on the left-hand side or on the right-hand side. Okay. Do you have any questions for this part? Okay, so you don't have to, solve it all the way until y is equal to some x. Okay, you don't have to do that. You can leave it like this. It's also fine. Okay, part C. Part C, y's derivative is equal to y squared minus x squared. Okay, so now is it still separable? It's not separable anymore, right? It's not separable anymore. Why? Because, there's no way you can move everything about y to one side, right? And everything about x to the other side. Because now it's not only multiplication, it's also addition and subtraction. Whenever addition and subtraction is involved, it's very hard to separate x and y with y. Okay, but here, you notice that it's another type of ODE. Because if you write dy over dx in this way, you can see it is a homogeneous ODE. Okay, you can see that it's just a homogeneous ODE. What does that mean? Right, it just means on the right hand side, you can see the top is square, right? The power is 2. The bottom is also x times y. Together the power is still 2. So the top and bottom has both have the same power. Right? It's considered a homogeneous. And the left hand side is just dy over dx. Okay, the right hand side, the top and the bottom have the same power. Okay, then it's a homogeneous ODE. And for homogeneous ODE, we have a standard method, right? We can let y to be v times x. Okay, we can let y to be v times x. Okay, and what is this v? This v is still a function, right? V is an unknown function of x. Okay, so v is not a constant, it's an unknown function of x. Right? So now we can do the work. For the left-hand side, what is dy over dx? So now let's assume y is equal to vx. What is dy over dx now? So now you use a product rule, right? Product rule, u times v's derivative is u's derivative times v plus u times v's derivative. Okay, so dy over dx, you differentiate this part with respect to x. So it's dv over dx times x plus v times dx over, dx over dx, which is just 1. So you differentiate this part using the product rule. Okay. Then what about so let's write it down. So dv over dx times x plus v is equal to, so here the right hand side, because your y is vx, so y squared is just v squared x squared minus x squared. And here x times y is vx. Okay, so the right hand side you can simplify it. You can see there's an x squared on both parts, right? So you can cancel them out. It will be just v squared minus 1 over v, right? Which is just v minus 1 over v. Okay, now it seems much more solvable because here v, right, cancel out, and now it looks like we are getting a separable ODE. Okay, you can see here it's truly separable now. So it's v dv is equal to negative 1 over x dx. Not v du, v dv. Okay, then you treat it as a separable. So integrate both sides. So the left is half v squared. The right hand side, right, it's negative. No, it's ln, right? It's ln. It's ln, it's negative. So if you just integrate 1 over x, you don't know x is positive or negative. The integration is just ln the absolute value of x. Okay, if you integrate x, 1 over x, and you already know x is positive, okay, then it's just ln x. So there's a difference. So it's negative ln absolute value of x, and don't forget about plus c. Okay, then last step, I don't want a v, I want y and x. So because y is vx, right? So v is just y over x. So this part is half y over x squared is equal to negative ln x, absolute value of x, plus c. Okay. Then you can simplify it, or you leave it like this, it's also fine. Right. So do you have any questions for this part? Okay, in summary, first you have to identify this ODE, right? You have to realize it's a separable ODE. Then you just use y is equal to vx, okay, and then do all the work. Then after you've done the work correctly, you have to identify this is a homogeneous ODE, okay, and after you do this standard substitution, you'll get a separable ODE, and then you solve that, okay, and last step, just sub y back, okay. So all the process, all the procedures is actually quite standard, right? You just have to do the calculations correctly, especially the integrations and differentiations. Right? You just have to be very, very familiar and comfortable with them. Okay, part D. Part D is also separable. So, sorry. It's not a separable, it's a homogeneous. Okay, again, why it's a homogeneous? Because if you move x to the right-hand side, it will be a fraction. And for the fraction, you can see all powers are 2, right? The bottom, it's a power of 2. The top here, it's a power of 2. So here, x times y, it's still power of 2, right? So both the top and the bottom, they're both of power 2. So you can do the same thing, y is equal to vx. Again, this v is a function of x, so dy over dx. Right, just do the same thing as you did in problem C. It's dv over dx times x plus v times 1. Right, so that would be the left-hand side. Okay, the right-hand side, just do the substitution. It's x times vx plus vx squared, over x squared. So you simplify, it's going to be v plus v squared. Okay, because the x squared on the top and x squared on the bottom, they can be canceled out. Right, so these 2v, they cancel out. So if we just dv over dx times x is equal to v squared. Okay, then now it's a separable ODE. Right? Move everything about v to the left-hand side, move everything about x to the right-hand side, and integrate. Right? Just do the integration. Okay. Here's negative 1 over v. Here it's ln absolute value of x plus c. Okay, and v is y over x, right? Just sub it back. So here it's negative x over y is equal to ln x plus c. Okay, and here there's one extra step than part C, because now you have, right, you have an extra piece of information. The initial condition y1 is 1. Okay, so when x is 1, y is 1. So you know that now. So when x is 1, y is 1. Okay, which means you can get the value of c, which is negative 1. Okay. Then this will be your final answer. Okay, this will be the final answer.